Okay, so Anthropic just put out a piece of research on AI that builds itself. Now, whether you agree with their conclusions or not, this is the kind of read that sets the direction of where the whole field is going. The core idea is recursive self-improvement. That is, AI systems getting good enough to design and train the next generation of AI with less and less help from us humans. Now, for years, the comforting story was that there is one thing that AI cannot take over, and that is the taste, which means knowing which problem is worth solving, which results to trust, and when to walk away from dead ends. However, their internal results show that things might be changing. Now, before looking at their results, I want to zoom out and take a step back. Systems that improve themselves against a target are old. This is not a new news. Now, in these kind of systems, you propose a bunch of variations. The system scores them against a fitness function. Then it keeps the winner and the loop repeats. That is basically what evolutionary algorithms have done for decades. And people have used them for things like chip design, different sorts of optimizations, and more. However, now we're seeing similar systems with generative AI. A more recent example of this is DeepMind's AlphaEvolve, which was able to beat the record that had stood since 1969 on scalar multiplications. And they even sped up the training of the models it runs on. Now, another good example is Sakana's Darwin Gödel machine, which pushed its own score on sweep benchmark from 20% all the way up to 50%. And a more recent example of this is AutoResearch from Karpathy, where given a set of criteria or fitness function, this system can run autonomous experiments and try to optimize for that specific criteria. Now, in every single one of them, the human hands the system the objective function and the benchmarks along with evaluation and the rubric. And the thing is that the machines are getting really good at optimizing for that specific objective function, which is defined by human. And that is basically just another word for taste that Anthropic uses. Now, you can map this directly to Anthropic's blog post. So Anthropic divides their work into engineering, which is writing the code and infrastructure. And then there is research, that is choosing the experiments and interpreting the results of those specific experiments. And their finding is that in engineering, Claude can take an underspecified problem and figure out the method on its own as long as you provide the goal. And in research, it can already match skills human at running a well-specified experiment. Now, the gap that is left in both is the judgment to choose the goal in the first place. And recursive self-improvement is exactly that the system should be able to decide on the goal in the beginning and then optimize for that specific goal. Okay, so how fast this boundary is actually moving. Now, for this, we're going to look at METR's Task Horizon benchmark. METR is an independent lab that measures how long a task in human time a model can finish on its own with 50% success rate. Now, one thing which I want to specifically point out is that y-axis that you see, this is human time, how long a task is going to take a human to perform. This is not for how long a model is able to run. This is a very misunderstood point that a lot of people don't really realize when they're discussing this specific benchmark. But the number has been doubling roughly every 4 months for how long the model can actually execute a task in human time. So the current chart puts it at 124 days, doubling time since 2023. Now, to make that concrete, Opus 3 back in March sat at about only 4 minutes. But Opus 4.6 this February is about 12 hours. And the latest Methods preview is about 17 hours, which is the upper edge of what METR can even measure right now. Now, let's look at Anthropic's own results, because I think this is where it gets even more interesting. So as of this past May, according to Anthropic, more than 80% of the code they merged is written by Claude. Before Claude code shipped early last year, the number was in low single digits. Now, according to them, typical engineer is now merging about 8 times as much code per day as they were in 2024. Now, we're seeing a substantial improvement or increase in how they are measuring productivity. Although the number of lines of codes is not a good measure, this should be more of the features that are actually put into production. They actually shared some interesting details of their internal tasks. So they run a recurring test where they hand Claude some training code and ask it to make it faster, basically training a model and then optimizing it for speed. So about a year ago, the best model got this about 3x speed up, while this April it hit about 52x. Now, on tasks like this, a strong human researcher needs 4 to 8 hours just to reach 4x speed. They also describe how Claude shipped over 100 fixes in a single month that cut a class of API errors by a factor of 1,000. And according to them, a similar work by an engineer could take them about 4 years. So this is kind of incredible. Now, there was also a very interesting other result that really goes into the heart of that taste question that we looked at in the beginning. So they took 9 real research sessions and then found the moments where human picked the next step and asked whether the model would have picked a better one, judged by somebody who already knew how the session turned out. So this is right in the middle of the session at a specific checkpoint. Now, Claude Opus 4.5 last November beat the human choice 51% of the time. The Methods preview in April is 64% better against a practical ceiling of 90%. Now, this kind of shows you that at a specific point, the model could start making better decisions about the taste or what next action to take. Now, this is critical because given a decision point, now it seems like the model can make better choices. Now, this is the part where I want to pump the brakes because there are several reasons to be skeptical. And to Anthropic's credit, they actually flagged some of those. Now, the first one is that 8x number. So it's basically lines of codes, which is famously a bad measure. It rewards quantity over quality, and Anthropic itself says true productivity gain is almost certainly lower than that. Or Hacker News, people pointed out that you can inflate commit counts with churn with code that gets written and then reverted back. Now, there was a survey in which the employees reported 4x productivity. And METR has separately shown that developers tend to overestimate how much AI is actually helping them. In reality, usually it's lower than the perceived productivity. Now, even that research taste chart has a catch in the footnote. So when they ran the reverse test, looking only at the moments where the human made a strong deliberate choice, the model beat it just by 20%. So the model is good at rescuing weak moves, not at outthinking good ones, at least not yet. And a lot of the headline numbers leans on internal preview models that you and I cannot independently test yet. And there is a deeper problem, the one that connects straight back to AutoResearch. Any system that optimizes a handed-in objective will eventually learn to game it. This is called Goodhart's law, which is basically reward hacking. The moment a measure becomes a target, it stops being a good measure. So lines of code is exactly that kind of gameable target. So the honest question is not whether the loop is getting faster. It clearly is. It is whether the loop is optimizing the thing we actually care about, or just the thing that is easy to count, because these systems have been known to reward hack. Okay, so with all that skepticism on the table, here is one experiment that I actually genuinely found very interesting. So Anthropic took an open problem in AI safety, roughly, can a weaker model reliably supervise a stronger one, handed it to Claude-powered agents and basically left them alone. Now, two human researchers working on the same problem for about a week closed roughly 25% of the gap. However, the agent was able to take it to 97%, which is kind of incredible. This is over 800 cumulative hours of work using around $18,000 of compute. And the thing is that in this specific case, they design every experiment themselves. Now, there is one specific caveat. The humans still chose the problem and still wrote this scoring rubric, which means the objective was still handed in from the outside. But within this boundary, the agents were not assisting the researchers. They were actually the researchers. This is Anthropic's version of AutoResearch, except pointed at a genuinely open question instead of a tuning loop and the objective setting. The taste is visibly creeping inward now. So this was class of model which were made available to select companies in Project Glasswing. It has already found more than 10,000 high and critical security vulnerabilities across major operating systems. Now, this has resulted in a very interesting thing. The bottleneck has now shifted from finding the bugs to patching them fast enough. Okay, so what do we do with all of this? Now, here's a very interesting thing that Anthropic kind of tried to point out in this specific article. So they're saying that if a research test is just another capability, something models are bad at for a while, and then they're going to quietly get really good at it. And the example that they provide is that the way they got good at explaining why a joke is funny, or passing a theory of mind test. Now, according to them, the story that we keep telling ourselves that humans stay in the loop on judgment has a clock on it now. Now, at the end of this whole lineage from evolutionary algorithms to a lab running its own pipeline is a system that does not just optimize our objectives, but starts setting its own. That is what fully recursive self-improvement actually means. So if you're building with these models today, the practical read is that your leverage is moving away from the ability to just writing the work and towards specifying it well and checking it. And that is its own skills worth getting good at. This is going to be really important for you. Now, they talk about this S-curve in terms of capabilities. Now, they say that we have not seen this curve bent yet, but it could. These actually usually turned out to be not exponential, but S-curves. And there is a real bottleneck in compute and human review that could slow the whole thing down. Right now, the humans still clearly win in the wide view, seeing the big picture and thinking past the task in front of us. The open question, according to this report, is with how long that is going to actually last. Now, towards the end of the video, I do want to share some of my own thoughts on this article. The first thing is a lot of people are pointing it out that Anthropic is about to do an IPO, and that's why they are releasing reports like these to show that there is a potential takeoff point. Now, I would be a little skeptical about that. Anthropic has been releasing some really interesting technical reports before this, so I don't think it's related to the IPO story yet. They also talk about 3 different scenarios. I'm not going to go into that because I think that's more on the sensationalism part. However, I would say that these systems are definitely getting better. Now, recursive self-improvement is still far away, but the intelligence that we're seeing right now is still very jagged. So it is really great in some points and really bad in other areas. We're nowhere near something like AGI because these are not journal intelligence systems yet. But for specific tasks, I think these are getting really, really good. And you should actually take note of that. Anyways, do let me know what your thoughts are on this article. Link is going to be in the video description. Thanks for watching, and as always, see you in the next one.